Okay, guys, so we're going to finish the sensory system structures and functions today. So, yesterday we went through eyes and ears, and I'm not going to lie to you, those are the most too complicated in that order. So, today we're just going to touch a little bit on the other three. So, first of all, oh my gosh, Eskimo kisses, guys. Don't do this. This is not social distancing. We're going to talk about the nose. So a lot of this is going to be repeat from respiratory. So we're going to move pretty quickly. Remember, nares is a fancy word for your nostril. So you have a right and a left nair. Cilia is hair. So nasal cilia are your little nose hairs. And the septum is the dividing partition, the thing that divides your right from your left nostril. So the only new thing here is olfactory epithelium. So remember that you see because of light and you hear because of vibrations, and all those things are magically turned into nerve impulses that get sent to your brain. Well, you smell because of your olfactory epithelium. So basically, little particles in the air reach this little patch of skin that's about the size of a postage stamp that's way up at the top of your nasal cavity. And it magically turns those little particles into nerve impulses. Well, not the particles themselves, but it senses the little particles and then interprets that as a nerve impulse that gets sent to your brain. So I'm going to show you. So here is like your nasal cavity, right? So you breathe air in, and then here's your nasal cavity. So this picture right here is showing you the olfactory epithelium. So say there's flowers, well, little particles of the flowers go up and up and up, and then you get to this little bulby thing, and those are picked up by neurons here, and the neurons cause an action potential, cause an electrical impulse to go up into the brain. So please note that this is nasal cavity, so there's air all in here, and then right there, that's brain. So if you've ever heard of like the brain-eating amoeba that people get when they go swimming in water, usually how does it get into the brain? It gets forced up your nose. So like you fall out of, say, a whitewater rafting thing, or you jump from a high height into water, and that water forcefully gets shoved up into your nose. Look, there's like little connections here straight on up into the brain. So that's how it gets to your brain from your nose. Talking about the tongue now. Ew, guys, it's your mouth bicep. That's so weird. So remember that it is muscle, and it is voluntary. It is skeletal muscle. So it's legit a mouth bicep. So your curriculum is going to say papilla. This word right here means taste buds. Just so you know, the papilla are the ridges on your tongue. So I'm sure you probably have heard that your tongue has ridges on it, just like your fingerprints are ridges. Very similar. In fact, fingerprints, those are called papilla as well. Anything that has like a little ridge or little bumps in it, little like these over here, you see with the little like mountain ranges, those are all called papilla. It's actually, your taste buds are on top of the papilla. The papilla themselves aren't your taste buds. Your taste buds are on top of it. But there's a test question that says like, which of these words is papilla? And the answer is taste buds or something like that. So just oversimplify it for them, but remember that it's not exactly the same thing. So these taste buds, just like the olfactory smell bad. So olfactory epithelium picks up on little things in the air, and your brain interprets it as what you're smelling. These pick up on things that you eat, and your brain interprets it as how it tastes. I would say that smell and taste go hand in hand. Taste is actually a very weak sense. I know it hurts my heart too, because chocolate is life, but it doesn't do much by itself. A lot of what you think you taste, you actually are smelling. To prove that, you ever been sick and things taste different? Well, it's because your nose is stopped up, and so now you can't smell it. Or have you ever taken a really bad medicine and someone tells you to plug your nose before you swallow it, so you won't taste it as much? That's legit. That's true. Because if you can't smell it, it takes part of what your brain was interpreting as taste away. Taste by itself is actually pretty weak. All right, just a couple little fun trivia things. First of all, taste is the weakest of the five senses. I already talked about that. You have over 10,000 or almost 10,000 taste buds all over your mouth. Even if some of them are like in the roof of your mouth. And everyone's tongue print is different, just like fingerprints, but it's not as easy to dip your tongue in ink and put it on a piece of paper. So we use fingers. This, I want to know who this is. This is Richard Simmons, I want to say. Gene Simmons. Gene Simmons. Richard Simmons, the workout guy. This is Gene Simmons. This is a band called Kiss. That's all. He's got a freakishly long tongue. He's like super famous for that. All right, and then skin. Again, we're going to touch on this super, super briefly because our entire next unit is skin. So you have an outer layer of skin. That's this tiny little bubblegummy pink part. It's avascular, meaning it doesn't get blood, and so it's dead. All the stuff that you see on the outside is dead. You have dermis, which has better PR people because it's called your true skin. That's the whole kind of, I don't know how to describe this color. Dots, gray dots. You know what I'm saying? The whole thick middle layer right there is the dermis. And then subcutaneous is just fat. It's adipose. So all the yellow down here that you see is fat. You have touch receptors and temperature receptors and pain receptors all in that dermis layer, like are things in the dermis layer. Look how busy that is. That is not social distancing structures. So touch receptors are like light skin touch. There's this cool thing where if you take two toothpicks and you put them real close together and you have someone close their eyes and you touch them very lightly, usually if they're real close together, the person can't tell that it's two different toothpicks. They can only pick up on one thing touching them. You have to get them weirdly far apart for the brain to recognize that there's two separate things touching it there. Temperature sensors, you have both hot and cold temperature sensors, and then pain receptors. So this is more deep touch. So touch these tactile corpuscles, they're light touch. Pain receptors are deeper. And we're going to talk about the main thing I want you to get here is there's two different weird types of pain. I mean, there's a lot of different types of pain, but these are weird types of pain. So this first one is called referred pain. Referred pain is where like you got hurt here, but for some reason your body hurts over here. Like you feel the pain over here. So perfect example of that is a myocardial infarction. Remember, that's the fancy word for a heart attack. Some people have an MI, meaning that their heart is actually what's being damaged and hurting, but weirdly they will feel it in their shoulder or even up in their jaw. That's a perfect example of referred pain. One that happens a little less frequently is appendicitis. So with appendicitis, your appendix is in your right lower quadrant, so the right lower part of your abdomen. And when you have inflammation of that appendix called appendicitis, generally that's where you should feel that pain, right in the right lower quadrant, because that's where it is. Every now and then, it's pretty rare, but every now and then someone will feel it in their left lower quadrant. And that's really dangerous actually, because it takes doctors so much longer to figure out what's actually wrong, because they don't, when you hear left, you don't think appendix. So sometimes referred pain can be tricky and can take longer to get diagnosed. Phantom pain. Phantom is like a word for ghost. Let me go back. Phantom pain means you're experiencing pain in something that's not there anymore. So let's say people with really badly uncontrolled diabetes, sometimes we have to amputate feet or entire legs from them. Even after, let's say we cut off their left foot, they will still feel pain or itching or some sort of weird sensation in that left foot that they don't have anymore. It's super weird. It's not well understood. Some doctors think that maybe like the neural representation from that left foot shifted to somewhere else on the body. So like maybe it's actually their, right butt cheek that's itching or something. And for some reason, their brain has just interpreted that as left foot because it moved there when they left that left foot. It's super weird stuff, but it happens a whole lot. All right, weird things. When your curriculum first gave me this PowerPoint, it was super wrong. I left this in here to tell you how super wrong it was. So it says our eyes are always same size from birth, but our nose and ears never stop growing. Literally, both of those are false. Your eyes absolutely still grow can you imagine a baby with human-sized eyeballs? I wouldn't even fit. That's stupid, guys. But also, you know how like bad vision gets worse for a while? Usually it levels off in your mid-20s. It's as bad as it's going to get until you're super old, and then it's bad vision for another reason. The reason that it gets worse as you're aging and you have to keep getting stronger and stronger prescription glasses is because the shape of your eyeball is changing, and it's usually that shape that's causing the bad vision to begin with. Also, the ears and the nose, they don't keep growing throughout your whole life. It's just that when you get old, everything starts to sag a little, people. I'm not going to lie. And so the ears and the nose get a little saggy as well. Okay, that's all, guys. That's the day. Good job.